Welcome to geometry.
Yeah, welcome.
You are going to learn geometry this year.
And we're here to tell you how it connects to the world.
We will teach you this through bridges, blueprints, and monuments. Now let's go. We can see this in bridges. Bridges! Bridges! We can see this on this bridge. There are many triangles creating a trapezoid. Triangles are used on the sides of the bridge to not only bear the weight of the cars on it, but also to bear the weight of the bridge by itself. So it has enough support. And engineers identify all points where the weight of the bridge falls, or the weak points. And then they use geometric shapes to build a strong structure. We can see this in bridges. Bridges! Bridges! We can see this on this bridge. There are many triangles creating a trapezoid. Triangles are used on the sides of the bridge to not only bear the weight of the cars on it, but also to bear the weight of the bridge by itself. So it has enough support. And engineers identify all points where the weight of the bridge falls, or the weak points. And then they use geometric shapes to build a strong structure. It's like this because triangles are the strongest geometric shape, and the reason of this is because triangles have the largest base with the smallest surface area. Engineers use these shapes to build the strongest structures, just like bridges.
Bridges don't just come out of nothing. They have origins, also known as blueprints. These are created by engineers using mathematical equations and geometric shapes to create a flawless design that are then transformed from paper to real life.
Blueprints are used to construct skyscrapers, bridges, monuments, houses, and even a simple backyard shed.
Blueprints use straight measured lines to construct 90-degree angles, which are used to make simple or elaborate floor plans on grid paper. The starting image uses translation to make the same image, but scaled down to fit on an average size of blueprint paper. Otherwise, we would be dealing with pieces of paper the size of houses.
Some details in these include stairs. A simple set of stairs include angles as well as slope. Builders use blueprints to build the stairs at 90-degree angles. Slopes and staircases cannot be too steep. Of steps, the distance of each stair is a factor that affects the slope. A great example of steps is our next picture of the Eiffel Tower with 1,710 steps.
The Eiffel Tower in Paris, France is a monument that uses geometric shapes of a triangle to hold itself upright, weighing in at around 7,300 tons of iron.
That must have been some blueprint.
And it was, Evan. One of the oldest monuments in the world are the pyramids, and each block is 2.5 tons. It has a total weight of 5,750,000 tons.
Analysis. How many blocks did each pyramid take?
Approximately 2,300,000 blocks.
It has survived this long and with that much weight because in exactly 51.5 degrees on each side tilt. This means geometry is being used in 2630 BC when the ancient Egyptians built the pyramids of Giza. The king's chamber is also involved in geometry. The Egyptians used triangles to find the right angle to make the perfect rectangular prism. Geometric shapes were used to create large square base, so wouldn't you guess, triangles.
It's all connected.
Wake up, America.
Architects use geometry to make stable and beautiful structures like the Louvre in Paris. Architects use rhombus-shaped glass panes to create their subterranean pyramid-like structure made completely out of glass. The Louvre has 675 glass diamond-shaped panes with 118 triangular panes. The architects used the pyramid to make the structure stronger and used diamond-shaped panes to make it so the glass won't break from the pressure placed on them. The glass diamonds and triangles make the pyramid 72 feet high and 116 feet wide. The pyramid was created to be a piece of art and a geometric marvel.
The Gherkin in London is a great example of modern architecture and geometry. Like the Louvre, it uses diamond-shaped panes of glass. The Gherkin was built to maximize natural air ventilation by using 6 triangular wedges cut out of the circular plan for each floor. By adding these geometric shapes, it increased air ventilation and lighting to save on energy. The Gherkin uses 50% less energy than comparable buildings its size.
So we've seen how geometry was used in modern architecture, modern art, and also it was used in 2000 BC by the ancient Egyptians.
We hope what you heard today can help you with your geometry this year. And I hope that we touched all the bases what we should have taught you also.
This is how geometry is used in your daily life and how it could be used to help others and create marvels.
Yeah, marvel.
So far, we've seen how geometry was used in modern art, modern architecture, and even in 2000 BC when the Great Pyramids of Giza, used by the Egyptians. Geometry has been used for many years, and hopefully you have taken something from this.
We hope that what you heard today will help you with geometry this year. We hope that everything we said touched all the bases and gave a satisfactory explanation for how geometry affects day-to-day life.
Geometry!